Hello dear student, this is Mr. Hitesh Patel, Assistant Professor, LJ Institute of Engineering and Technology. In this video session, we are going to discuss of the subject Basic Mechanical Engineering. Today in this video session, we are going to discuss some numericals of chapter number 3 Properties of Gas. So let's start with the first numerical. The numerical number 1 is 5 kilogram of air is heated from its initial volume of 0.5 meter cube to final volume of 1.3 meter cube at constant pressure 4 bar. Determine heat supplied, work done, initial and final temperature of the air. Take Cp is equal to 1.005 kilojoule per kilogram Kelvin and R is equal to 0.287 kilojoule per kilogram Kelvin. Here in this numerical you can see that there is a mass which is 5 kilogram and the air is heated with initial volume, that is V1 is equal to 0.5 meter cube and final volume, that is V2 1.3 meter cube, and here the pressure remains constant. That means P1 is equal to P2 is equal to 4 bar, that is 4 into 10 raised to 2 kilopascal. Okay. Now find out the heat supplied, that we need to find out Q, work done W, initial and final temperature T1 and T2, and Cp they have given us 1.005 kilojoule per kilogram Kelvin and R is equal to 0.287 kilojoule per kilogram Kelvin. Okay. So we need to find out heat supplied, work done and initial and final temperature. So here the process is constant pressure process, and we know that for constant pressure process the equation for heat supplied and work done, we know that for constant pressure process work done W is equal to P in bracket V2 minus V1. Heat supplied, we know that heat supplied Q is equal to del W plus du, and we know that the equation of del W is PV2 minus V1 and equation of du is M CV T2 minus T1, and by solving this we get Q is equal to M Cp T2 minus T1, and we need to find out T1 and T2. Okay, so let's start the numerical. So first of all we have mass M is equal to 5 kilogram and we are finding Q, W, T1 and T2. For this we required value T1 and T2. So we have the ideal gas equation, that is P1 V1 is equal to MRT1. From this equation we get the value of T1. So we know that the value of pressure is 4 into 10 raised to 2 kilopascal, volume V1 is equal to 0.5, mass is 5 kilogram and R is 0.287 and T1 that we need to find out. So from this equation we can find out temperature T1 as 139.37 Kelvin. This is answer 1. Now we need to find out temperature T2. For finding temperature T2, we know the relation for constant pressure process. The ideal equation for the relation is P1 V1 by T1 is equal to P2 V2 by T2. But we know that this is constant pressure process. So P1 is equal to P2. So final equation becomes V1 by T1 is equal to V2 by T2. From this equation we get the value of T2 as 362.36 Kelvin. Now we have the value of M, Cp, T2 and T1, so that we can put it in equation of heat supplied, that is Q is equal to M Cp T2 minus T1. By putting value in this equation we get the value of Q as 1120.52 kilojoule. Now next is work done during the process, that the simple equation W is equal to P in bracket V2 minus V1. By putting the value we get 320 kilojoule. So dear students, this is all about this numerical, very easy numerical. Now let's start numerical number 2. 5 kilogram of air is heated from 25 degrees Celsius to 150 degrees Celsius. Here you can see that the mass of the air is 5 kilogram. Initial temperature is 25 degrees Celsius. Final temperature is 150 degrees Celsius. Determine specific heats means Cp and Cv. Change in internal energy, that is du. Change in enthalpy, that is delta H. But take R is equal to 0.287 kilojoule per kilogram Kelvin and gamma is equal to 1.4. Here they have not mentioned that which process are using or we need to use in this numerical. But here you can see that there is a change in temperature takes place. Okay, so this is definitely not constant temperature process, because in this numerical you can see that the temperature rises from 25 degree to 150 degree Celsius. So in this numerical, this process is definitely not a constant temperature process. Okay, so with except constant temperature process, all the equation related to change in internal energy and change in enthalpy remains the same. In all processes, the equation for change in internal energy is du is equal to m cv t2 minus t1, and change in enthalpy delta h is equal to m cp t2 minus t1. Okay, so we can use any process for this for solving this numerical. So let's start. The first r and gamma is given. We need to find out Cp, Cv, delta U and delta H. We know that Cp is equal to R gamma divided by gamma minus 1, and Cv is equal to R upon gamma minus 1. So first of all, Cv is equal to R divided by gamma minus 1. We have the value of R, that is 0.287, divided by gamma, that is 1.4 minus 1, that is 0.4. So final equation will be 0.717 kilojoule per kilogram Kelvin. Now we know that Cp minus Cv is equal to R, so Cp is equal to Cv plus R. By putting this value in this equation, we get the value of Cp. Next we need to find out that is delta U. Delta U is equal to m Cv T2 minus T1. We have the value of mass, that is 5, Cv 0.7175, T2 423 Kelvin and T1 298 Kelvin. So final equation will be, final answer will be 448.43 kilojoule. Next is delta H is equal to m Cp T2 minus T1. We have mass, we have Cp, T2 and T1. By putting all the values in this equation, we get 627.81 kilojoule as answer. So this is all about the numerical. If you have any queries, then you can write down your comment in the comment section. Let's jump to the next numerical. So numerical number 3, a cylindrical vessel of 1 meter diameter. So diameter is 1 meter, 4 meter length is 4 meter, has a hydrogen gas at a pressure of 100 kilopascal and 27 degrees Celsius. Okay, so here pressure is 100 kilopascal and temperature is 27 degrees Celsius. Determine the amount of heat to be supplied so as to increase the pressure to 125 kilopascal. Okay, so here we need to increase the pressure from 100 kilopascal to 125 kilopascal. Okay, and for hydrogen, take Cp is equal to 14.307 kilojoule per kilogram Kelvin and Cv is equal to 10.183 kilojoule per kilogram Kelvin. So here diameter is 1 meter, length is 4 meter, pressure is 100 kilopascal. Okay, temperature is 300 Kelvin, pressure P2 is 125 kilopascal. They have given us Cp and Cv. Now first of all we need to determine which process follow in this numerical. So here you can see that, see this, the cylindrical vessel is filled with hydrogen gas. Okay, so we know that the volume of the cylindrical vessel remains constant throughout the process. So this is the numerical of constant volume process. Okay, and we need to find out the amount of heat to be supplied, that is del Q, and we know that the equation for del Q is m Cv T2 minus T1. Okay, so for finding heat supplied during this process, first of all we need to find out the mass, because the heat supplied during constant volume process equation is m Cv T2 minus T1. We have the value of T1 but we don't have T2, so we need to find out T2 and mass m. Okay, so first of all for finding the mass we have standard equation, that is P1 V1 is equal to mR T1, but we don't have volume. So first of all we are finding volume, and we know that the volume of the cylindrical vessel, that is pi r square L. Okay, so pi r square L, value of pi we know that the value of r, that already given the diameter is 1 meter, so diameter divided by 2, that is radius r, so 0.5 square into length is 4 meter, so volume is 3.14 meter cube, and volume V1 is equal to V2 is equal to V, because volume of the system remains constant throughout the process. Now next we need to find out that is R, because for this is hydrogen gas. So Cp minus Cv is equal to R. By putting the value of Cp and Cv we get R, that is 4.124 kilojoule per kilogram. Now we need to find out T2, because they have already given us T1, and the relation between pressure, volume and temperature during constant volume process, that is P1 V1 by T1 is equal to P2 V2 by T2, but during constant volume process V1 is equal to V2, so final answer will be P1 by T1 is equal to P2 by T2, and we get T2 is equal to 375 Kelvin. Now we can easily find out the mass, that is P1 V1 is equal to MRT1 from by putting the value of P1, that is 100 into 3.14 meter cube is equal to mass that we need to find out. R is 4.124 and T1 is 300. We get mass as 0.2537 kilogram. Now we can easily put this value QV is equal to M CV T2 minus T1 in this equation by putting the value of mass, CV, T2 and T1. Their mass is 0.2537 that we have already find out. The value of CV is 10.183 that already given in the numerical. The value of T2 is 375 and value of T1 is 300. We get 193.83 kilojoule. So this is the heat supplied during the process, during constant volume process. So this is all about the numerical. If you have any queries in this numericals, then you can write down your comment in the comment section. Thank you for watching my video.